Okay, so we looked at removing the greatest common factor, and then we looked at factoring trinomials, but sometimes the greatest common factor was 2 terms, and then we went on to 3 terms. Now we're going to go back to 2 terms. So let's take something like x squared minus 9. We call this a differences of squares in the title. So in the steps, in the English sentences off to the right, we're going to set up 2 sets of brackets. First of all, before that, we're going to identify that 9, the square root of 9 is 3. We have to be able to square root both numbers. So we're going to put a plus sign and a minus sign in between them. And we're going to go, what times what is x squared? X and x. What times what is negative 9? Positive 3 and negative 3. Called the differences of squares. Just set up your brackets and think about what goes there. Obviously, check your answer. X plus 3, x minus 3. FOIL it out. X times x is x squared. X times negative 3 is negative 3x. Positive 3 times x is positive 3x. Positive 3 times negative 3 is negative 9. And the middle terms go away, and we're left with x squared minus 9. Same as we started off with, check mark near our answer. One big reminder, we're working on differences of squares, which means minus. If we have something like x squared plus 4, that's the answer. We cannot factor it. Okay, further, we have 4x squared minus 36. Now, both of these things are perfect squares, and we can do an alternate method. But let's do it in order. This is a 4 in front. Let's do it in order. So we learned a GCF first in this chapter, so let's try and do that. So let's see if we can take out a 4. 4 open bracket, x squared minus 9. Look at that. We just did that one above. So 4 open bracket, x plus 9. Excuse me, x plus 3. X minus 3. Fully factored. So, circle your answer. Now, you could FOIL it out and then distribute the 4 like you can see in the notes and then check your answer or whatever. Okay, let's go further down the page for a moment. 4x squared minus 49. Now, can you take out a 4 or a 2 or a greatest common factor out of both? No. So, what we want to do is, reading from the notes, figure out what's being squared. So, an unnecessary step is what's shown in the notes. Figure out what's being squared. Well, 4x is just 2x all squared, and 49 is just 7 all squared. So, you know what? I'm going to write that step. So we have 2 things being subtracted that we know that they can be squared. Put a plus and a minus. Put the 2x first and the 2x first, and the 7 and the 7. Circle your answer. So remember, set up your brackets. Well, first of all, figure out what's being squared through change of base. Go back to grade 9 exponent laws to figure that stuff out. Then, we don't have to do the middle step. You can just set up our brackets and do it. Check your answer, FOIL it out, whichever. Look at the notes. Okay, so, you know what? Let's go up to the right a bit. There's some stuff in a square. I'm going to write it down. X to the 4 minus 1. Well, we know that these are both perfect squares, so we can set it up. Plus and minus. Well, what times what is x squared? 4. X squared and x squared. What times what is 1? 1 and 1. Now look at this first one. It's a sum of squares, so we can't touch it. X squared plus 1. Look at this next one. It's x plus 1, x minus 1. The same process that we just did. Circle your answer. Look at the example down below. It's done again with different numbers. Look at the algebra off the right. It's done with letters. I'm going to box that because it's in a box in the notes, whatever. Okay, now below the box, I'm not showing the second example in the box, 9x squared minus y squared. Well, again, I'm going to skip that middle step. I'm going to skip a line just to keep stuff parallel. Whoops, that second set of brackets isn't big enough. I'm just going to think about it. What times what is 9x squared? Identical. 3x and 3x. Put a plus and a minus sign. What times what is y squared? Y and y. Circle your answer. So let's see a funny one. Negative x squared plus 49. Well, you can rearrange the order of the terms. Then you have 2 things being squared. 7 squared is 49, plus x minus x, and leave it that way. Or look in the notes off to the right, like FOIL it out to check your answer, or look in the notes off to the right. So let's take it from the second line. We can take out an x, negative open bracket, go back to the first section, remove great factors of negatives. Now we want to take out a negative and rearrange the order of the terms at the same time. So we have a negative x squared above, so negative times x squared. And then we have a positive 49, so we're going to need a negative 49. Then we just have a negative in front of our brackets, plus minus, x plus 7, x minus 7. These solutions are equal to each other. Whatever. The bottom right's a fun one. I'm going to do it bottom left because the video is in the way of bottom right. 1 minus x to the 10. Well, set up your brackets, plus minus. 1 squared is 1, so 1 times 1 is 1. And what times what is x to the 10? We learned from exponent laws that we need x to the 5, and again x to the 5. Circle your answer or skip lines when necessary. I'm going to put that minus sign again a little bit above. That kind of looks like an equal sign. I'm going to erase both of them. I'm going to put the minus sign above, and I'm going to circle in a different color. So all sorts of interesting differences of squares. Now let's take a look at some combinations. GCF, trinomials, and differences of squares.